Hello, and welcome to Coding with Gerph. Yeah, hopefully today we're going to be doing some coding of the comments for immediate values on the debugger. So that's updating the disassembler with some additional comments. But we've got a little bit to finish off here because apparently I didn't quite finish things last time, so we'll have to just finish that off rather quickly. It's not going to matter very much, but it looks like we're in the midst of we've made the changes for the FPA floating point instructions, and yeah, looks like everything was pretty much all committed. Not all pushed though. What have we got in there? What have we got as the last thing we did? Cleaning up, and oh, I deleted the final little bits of the Python code. That's right. So I'll just push that, and then we should be able to go and merge that branch. Did we have a PR for it? Not that one, please. I want the actual project. Where's the project? Maybe I just have to stick it in here. DOM. Nope, that's wrong. It's Gerph/DOM. I'm doing a good start here. Right. Hi Andrew, and hi Alan. Seems like we've got a couple of well-known people here, so this will be quite nice. So I was doing a pull request. I was doing a branch. I didn't pull request it. If I didn't pull request it, I can't be bothered to go and do that. So let's just go and push it instead. So merge it instead. So check out master, merge, add FPA disassembly. There we go. Right, and then push that. So that'll get merged now. That's me. Oh, hang on, we're not up to date. That's interesting. Ooh. Undo commit. What happened there? Undo commit. Let's go back one. Go back to where we were. Okay. CI build has been broken. Interesting. Stash that lot away. So just hide that away and go back to where we were. So add FPA. Let's see where we were. Right, so here's where we are now on here. Here's where master is. Origin master. But there was also this is just the ones that I did for the stashes, isn't it? Not quite sure about that. That's a little bit odd. Well, okay, let's just go back to check out master. We must have pushed it. I don't know, let's just do a pull anyway. Maybe I did push it then. Oh, that's what had happened. I'd made changes to master and I had merged it, but then I made a change on the branch for cleaning up the Python code. Right, that's all I did. So what I'm going to do is I'm going to just cherry pick that onto master. I'm in master, cherry pick. That's one change because it shouldn't have gone on there. Right, there we go. Push that. Okay, I'm now up to date. Oh dear me. Right, so today I'm intending to do comments on the whatever they're called, instructions, the immediate values. So if we go back to the let's not go to the code, let's go and have a look at a disassembly. So if we try disassembling something, we'll be able to see what actually happens. And the easiest way to disassemble something is do paradev. No, I don't want to run band limit. I want to use RM32. Oh, I don't know what I'm doing. No. Load the module. RM32 dot debugger. Slash debugger. This is the. Oh, come on, brain. Why has it not been built? Oh. I probably cleaned it, didn't I, before I finished up last time. Oh, I got some warnings in there. Interesting. Might need to fix those as well. And an smprintf warning. No, I'm not going to worry about that one so much. Okay, so yes, now I've got the module. Do we have a... Oh, I've got lots of history here. RM32 slash debugger. I'm doing lots of testing with message trans of late, so I've got a lot more bits in there. Right, so this is, yeah, makes the module, and then, yeah, that's good. So make the module, and then run our debugger command. So that's floating point, and then we've got the regular Is it A for disassembly? It's probably D for disassembly. A is the architecture disassembly, that's right. Right, so all of these have got like numbers in them, some of which are not important, like these ones here, we can see what they are, but other ones end up being quite big. So that's addresses, and these are obviously values. So it would be useful to be able to have a decoder for that. If I don't load my module, so the new module, I skip loading the new module, and instead we just run it with the standard Pyromaniac debugger, we get a slightly different output. So the bits we get here are, well, on the CPSR we actually get just a decoding of what the instructions are. Not instructions, sorry. Oh, brain's not very good today. What the CPSR values are that are actually being set. These ones are, this one's telling us what the negative value actually is, which is quite handy. Again, the negative value being decoded. And then further up here, yeah, some other bits that tell us what the values are, and sometimes what they're shifted by, which is quite useful. So that's quite good. Yeah, this one also tells us what bit it is as well, bit 19 set. So I'm going to try and do some of that today. See how much we get done, but we'll have a go. All right, so what's going to be the easiest way to do this? First thing I think we want to do is identify the actual values. So this one here, mod1, number 128. There, that's not too hard to do. We can go and do that. So let's actually probably the easiest way to do this. Basic. So I'm going to go and try and get out the values that I had. So that's going to be, put this in basic, please. Thank you. 1000 mov r1 comma number 54. What ending there? So 654 and 654. No, that's not a good constant. 650. There we go. That'll do. So that value there, I want to be able to get into a quick test. So let's do a quick test with that. It would be easier to actually write some tests, some proper tests for this now. I'm not going to bother. I'm just going to try doing it this way just because I'm being super lazy. Command is memory A 9000 E3A01 E565, and then actually does that actually write out what the disassembly was? What? Oh, error, bad number, empty string. Memory alter 9000. That is the right syntax, isn't it? Surely. Am I being stupid? Have I misimplemented memory A in Pyromaniac? Memory A, whether it's a byte, the address or the register, and then the value. Memory A, we're not doing a byte. Okay then, let's debugger. Just see if we've got any additional debugging on this. Okay, well that's kind of fun. This window over here is Pyromaniac, so let's pull up the source to it. There we go, source to Pyromaniac. And come on, sit at the top. I want to find debugger.py. So command memory A. So memory A takes an address. Should really put those square brackets around there, but it's not important. Then we get the memory parameters, and it complains about extra parameters. But memory A params also looks like it decodes other things. So presumably memory A params is up here somewhere. Memory A params. It reads out a base address, a relative address, and some arguments, and then a value and some arguments. That looks right. If I don't include the extra parameter, what do we get? Do we actually get a prompt as we should? Yes, we do. New value E3A01 E65. Yeah, okay. So that works. But it doesn't work when I give it two parameters. Odd. I'm just going to be lazy and introduce some debugging. Memory A params args equals args, and then args2. There we go. Let's print it out the second time, and then I don't think we get to the third one. I think we generate an error before that. So let's just print those three out and then run it and see what we get. Bad number, empty string. But it didn't even print those out. Memory I. Where's memory A gone? I've lost memory A. There's memory A. If I was looking at the wrong function, apparently. Was I looking at the wrong function? I thought I'd found it. Oh, I must be stupid. No, memory A just does I just found it because I just put some thingies around it and I thought there were two sets of parameters. Memory A, no I did, no, I'm just getting very confused, aren't I? So this is meant to read the parameters, but it's not. Go into memory A params there. I've saved this file. Hang on, am I editing the wrong thing? I am. I'm editing the wrong thing, I think. This is in the PP, which is my place that I build the Pyromaniac for Windows, because PP is nice and short to type. Should be this one here, debugger init. Okay, memory A. Okay, slight digression there. Memory A params. Whilst I'm at it, I can just tweak those to have the things in there. At least that also tells me what I was doing wrong. Memory A param. Yeah, there, that's the ones. So, then args equals .r. Oops, not C. Args 2. I'll do a third one just in case. Right. So it thinks there's an empty string there. It hasn't actually moved on to it. I wonder why. So param, I thought param would have stripped things. I would have thought so. Left strip. Hang on, what? So there's a space there and then there's a string. Okay. This is where we look for may refer to a register, so we try and match a register. We don't find it. If we do find it, we do that. Hang on, what? If we found something that looks like a register, then try and find it in the architecture registers. And then trim it. Ooh, that looks wrong, doesn't it? Because that means that we're always going to trim to what's after that. I think that should go there. Wonder why my test didn't catch that. See, that's more like what I expected. That is a bug. That's not almost certainly a bug. It is a bug. Cool. So that's a bug we've got in Pyromaniac. Let's go and put test in for that. Test. PyModules debugger. Right. Memory A. How strange. Memory A is being tested here. But the value that I'm testing here starts with a letter. When I'm writing just a number, it works fine. But when I'm doing it with a letter, it ends up matching that regular expression. Okay. Memory A value base. It should be really called base plus value there, shouldn't it? And that's base plus value. Right. That's using bytes. So here I'm just going to do plus value alpha. why not let's use E3A01E65 so we actually get the same thing. All right. So now you get to see a little bit of my developing Pyromaniac, I suppose. So in order to do this, we need to now go, oh, I'm in a different, checking it out, master. Yep, I've got two files being tested. Make clean, so we've not got anything hanging around. Make tests, test equals PyModules, debugger. So what it should do is run through the text file that describes all of my tests after it's run the Python tests, and show that the new Pyromaniac is working. It'll take a moment or two. Yeah, it'll take quite a few moments because it's got a number of different tests to run through. But we'll see it. It's also running slower because obviously we're doing presentations and stuff. So, yeah, hopefully this will get through that because we've got quite a few tests in here. We've got all the show regs tests, all of these other ones, the memory tests here, and then memory A tests. I suppose I could have just cut out the memory A tests and make sure that works, but yeah, we'll see what happens. It's all looking like it's going to be good anyway. There are a lot of tests in Pyromaniac, but of course it can never be complete. So, well, it could be complete, I suppose. We could test every possible command in every possible combination, but then you've got to do it in every possible combination of what's in memory, and all. There's so many different combinations, it's impossible. So it's really about trying to test sufficient amounts of the system to be able to be confident that something is working. In this instance, I thought that editing memory with just a single value would be just fine. I also noticed as we're doing this that although I hadn't tested this, I've also not got a test for a particular register value. So I've not got a, if register R1 was specified there, it's not being tested like that, which is kind of interesting. Probably want to do that in the future. There we go. So here's the actual test we've just added. It's doing a disassembly of the bit beforehand. Before it was run, it was 0, 0. Not disassembly, a dump of it. And now it's 0, 0, and now it's become this value. These are both correct. So this is now a good test. So I'll just let it run the rest of them. I try to always ensure that it runs to completion. I don't like to stop the test once it's past the one that I've got, because then it would, if I stopped it partway through, it might not have caught something that had broken elsewhere. I could still break something elsewhere because this is only running the debugger tests. I could, in theory, be running all of the tests, as in all the tests up to across all the different modules, which would just take ages. When it normally runs, it takes about an hour and a half to actually complete, which is a lot of testing. But all that happens in the background whilst I'm doing other work. I just do my commits, push the tests, and the test system comes and tells me that things have become broken. There's a lot of things are interrelated, so it's quite easy to break something. It's also possible easily to go and break things in such a way that you affect the things you didn't realize you were going to affect. So if I was changing the disassembly code itself, not only would I be affecting debugger, I would also be affecting all of the tracing code that prints disassemblies whilst it's tracing what's being done, or exceptions happen and the like. So all of that code would potentially change as well. Well, not the code, the output would change, and we'd have to check it. But those are things that we always find in here. I think we're nearly done now. This is the additional flags for Debugger Plus. Oh, and then it kicks into these ARC64 tests. I probably don't want to run those. What if we started those? Maybe we started those already. Maybe it's done those. Maybe it's on. Oh, it's on the additional Swise ones. That's right. I should probably move this batch out. There we go. Right. So I've now got one set of tests that look like they're doing the right thing. If I have a look at the actual output here, see this is what it actually outputs. That looks good. So the way that I then make that the principle I'm using here is of gold masters. So gold masters are a set of output that you know is correct, and therefore you compare against in every run. So in this instance, I've got this particular file here. Oops, no, that's not right. Wrong command. So I'll just rename it from having actual on the end of it, which is the actual output, to be the gold master, which I've done wrongly. Test code. Oh, it's not in test data, that's why. There we go. Status test code. This one here. This is a new test, so I can add it. Fix debugger memory A. With instruction. Oh, actually, we could allow memory A to be given an instruction. Although then that would mean I would need to build an assembler into Pyromaniac as well. Yeah, could do that. Yeah, I use Capstone for disassembly, and there's another one that I can't remember the name of that I could use for assembly, but I don't think I'm going to do that. Anyway, this is all a big distraction from the original problem. Let me declare the change. This is a fix. Memory A now understands now, not the value starting with an alpha character previously would fail thinking that a register had been given. Okay. So we've got the change log entry, the new test results, updated test code, and the addition of the test. And go. Oh, don't push it just yet. If I push it right now, it'll go and start running the tests, and it'll run it on my server downstairs and on this machine as well, in order to test it on Linux and macOS. And I don't want it to run on macOS because I'm trying to stream a session at the moment. So that's now fixed. So we can go back to DOM and we can do our little test here. It should now go wrote word blah to there. Right, and that then we can do a quick test. Load module I'm32. So load our module and do the same thing. very slightly different output. Happy with that though. Okay, so we've got that being written. So now we can do command. The whole point of this was to do a memory I of 9000 plus 4. And in theory, we should then see the value. Hey! Right, so that says that its value is 1616. Okay, so that's kind of interesting because it means that we're getting, in this instance, we're getting out a decimal number, whereas in the Pyromaniac source that was coming out as a hex value. Maybe we can still do values on this because I can always go and tweak this number and go and make that like an 8 and we get a different value out of there. Oh, let's just make it that value. Make this F instead. Oh, you have to make that lower, don't you? Sorry, because that's actually a shift rotate right that it's actually using there. There we go. I've got a big number now. So I've got a choice of numbers there we can use. Okay, we don't need Pyro at the moment, so we'll move that out of the way. We can go back to here. If we have a look in wherever it is that we actually build up the strings, is it Rodis? Disassemble word. This calls out to the disassembler. We do a little bit of patching up with things. And then we put it into the buffer that we've been supplied. But here we go, we only put in mnemonic and then arguments. So what we could do here is we could work out what the actual immediate value is. So if I remember rightly, so disassemble FPA does all the work itself. Not going to worry about disassembling FPA. We're just going to look at this bit here. Both of these decode a word into D, and I believe that D itself can contain an immediate value. uint32 to im. Oh, but we don't know when it's actually valid. That would be interesting to know. We'll have a see. Let's see if we can actually print it out though. So if we've decoded it, we'll just do it here. No, I'll do it at the end actually. Where's the end of this code? This bit here. Yeah. Usually mnemonics in the case. Okay, so decoded im equals let's do it this way, I think. For d.im. Alright, that'll just help us to see what we've actually got. Oh, I need to actually compile this first, don't I? Let's go sample file, make file module, and then run the command. Immediate value equals that. That's pretty cool. But we don't know when im is actually valid, because it might not be valid for many different types of instructions. So what I'm going to do, what can I do? I need to decide whether this instruction is actually valid for decoding that way. What I might do is actually just compare the instructions, the character sequence for the mnemonic. That might actually be the easiest thing, because then we will not catch things we didn't mean to. In theory, I could build this into DARM itself, but it feels like a lot more work. So let's just try it this way. So I'll just try it this way. Why not? Only put that if we're doing stuff. So I'm just trying to think the best way to do this. I should just use a string and a comp, but is that going to be less efficient? I'm not sure. This is a MOV. Only print it out when we got a MOV. Probably, I think we should probably start building a comment. Buffer 128, probably reasonable. Star comments. Actually, we don't need that there, do we? Yeah. Oh. Then we set a comment to point to that when it's valid. Yeah, I'll do that. I'm going to allow for 128. Let me just double that just for a little bit of sanity. These could have constraints on them, but I haven't bothered. That's not what I wanted. Okay. If, oh, I forgot to assign comment null. Right, so what the idea here is I'm going to go and flag that there is a comment present, and if there is a comment present, we'll build it differently. If comment is present, comment is present, we'll do something different. So if we use it, minus 20. Semicolon. 20 going to be long enough? Go for it. Send S. Right, uint 32 im d.im. Right. So this could be a MOV or an MVN, move negative. If it's a move negative, then we want. I'll do MOV first. Let's just do one at a time. Be simple and not get ahead of ourselves on this. So here's our immediate. And if I wonder when DARM actually changes how it prints not immediates. Let's have a look. Append im. Oh. If it's less than 1,000, a hex 1,000, sorry, do it as a hex value. Otherwise, do it as a decimal value. If I was clever here, I'd actually change that to the and here, and then we'd have it not having to be fixed up later on. But I can't be bothered right now. Let's just leave it for now. That's not very good, is it? So even when it's doing a hex value, it's ending up doing a division in it. That's going to be terrible. No, don't fix different things. One thing at a time. Go back to here. Right. If im is less than OX1000 and im is greater than so that in it, DARM will have produced a constant as a decimal. So let's printf into comment buff You know, I could actually do this properly, couldn't I? SN printf into comment buff or size of comment buff. Ampersand equals ampersand and then immediate value. Otherwise, as a not as a decimal, but as a hex value. We'll click the decimal one. We'll do this as an unsigned there. Offset zip offset equals that right into that's the address of the offset, and then take off the amount of things we've written, which all is a bit tedious, but it should at least mean that this is a safe operation to do. And then if the comment is successful, do that. Build it. Oh, that probably won't work. Just try that. Oh, that did work. And it came up with a nice warning telling me that's broken. Cool. I'm not going to worry about that. SNPrintf isn't an issue for us right now. But if I do this now, run our test. No comment on the end. Why no comment on the end? Oh, I never told it there was a comment. Comment equals comment buff. Build it. Right. Happy with that. If we go back to the other one, so I changed this to E6, which was the other value. Oh, I probably want to check that that value is actually correct, shouldn't I? That, and now we've got 650 printed. Nice. Okay. With that in mind, I think we can now let's actually create a branch for us first. Right, this is a branch for add comments for immediates. Okay. And just a little bit of changing to add in the morph checks. Right. Added comments for the immediate instruction mov. That's the only one we're supporting at the moment. Fine. Immediates on. Mov instruction now given the comment indicating value present. Okay. So let's do some more, shall we? To do some more, I need to find out what some other instructions are. This is where it would be also useful to have some tests on it, so it actually test it live when we run things. So what's the easiest way to do that? Well, probably going to be to throw it at the test system. What tests are I actually running when we do this? So we're going to GitHub in the CI. The get CI here goes, builds the POSIX version, then goes and builds it through the build service, fair enough. We then go and build, give the output a version number, and then we go and do a release if we need to. So there's no actual testing properly of this, which is not ideal. I've got better testing in some of the other components that I've done. Not all of which have actually got the right things in them to make this helpful. But right now, what do I want to do? I'm not sure. If I were to because I still need to compare the output and check this. You know what I'm going to do? I'm going to be lazy and just say I'm not going to worry about it this time. I'm just going to make a note of what commands to use to do the testing. Because then we can reproduce it in the future, but I'm not going to make it automated right now, just for sheer ease. If I was doing this on my own, I would go into all of that, but when I'm doing work on my own, I find it a lot easier to go down rabbit holes and then unstack things and come right the way back to where I was, because I've got as much time as I need. Whereas when I'm doing it here, I am trying to do it quite quickly and not necessarily the best, just so that we've actually got something we can show. And the whole point of this debugger module is to show, look, you can port something, you can do it relatively well, and then you can clean it up later. The idea being, this module, as seen, has been made to work both in 32-bit and 64-bit. This can be true of pretty much any other module. And so it's not just me that needs to do this. At the moment, I don't know that anybody else is, so we're a little bit stuck on what we can do. So let's start by making some notes. Not start by, let's continue by using some notes, shall we? What should we call this? New file. Test notes. Markdown. Right. Notes for testing. The disassembly of the immediate constant. I'm going to have to open the window. It's got far too hot in here. There we go. Hopefully I'm not going to get dazzled. Well, that's not too bad actually. The window just looks like a part of a wall now. Yeah, it's not too bad. All right. Some immediate constants should be automated in the future. At present, the tests just being run locally for certain values. Following are useful test drive. Right, where do we go? There's this one here. This tests the instruction E3 A01 E65 and of course I could put these all in a file. Oh, wouldn't that be much more sensible? I'm being an idiot. I should put them in a file. Okay, so that's still useful. Let's do that. Yeah, okay, this is a nice digression. New file, folder, test code. What is that? New file. Make file. I'll create the actual content for that shortly. S and bin. Because what I'm going to do is I'm going to steal the code from one of the other components that I've got. Probably message trans, I think. Yeah, we'll just steal it from message trans. Sampler / no, actually that one there, in fact. Message trans. Okay, test code. Make file. So you can go on the right, you can go on the left. So this is actually the bit that's got the magic send it all to Pyromaniac to do test. Oh, we could just do that. I could just do that. Yeah, all right. So there's going to be a bunch of copying things around here, but this is not going to matter too much. For now, that's a good file. I'm not going to copy test. I'm just going to make the files. Header, please. I don't actually want any of these macros and things because I'm not going to be doing very much. I'm literally just going to be writing a simple S file in here. New file, immediates. Right. I don't actually need all that code. I just want the header bit. Actually, I only need the area section, which I could have worked out for myself. Yeah, that was a big waste of time. No matter. Immediates. Right. Just for simplicity, what I'm going to do is I'm going to make it reporting. Actually, I'll just make it return. If somebody tries to actually run this, we get a return. All right, so mov_r1 common number and 650 25 minus 2. Okay, let's start out with that. Go back to here. We're going to test code now and type make. It'll assemble that file, please. Thank you very much. We'll have a look in immediates here. So bin/immediates. There we go. That's assembled it, and that's my standard decoding. Ah, see, that's interesting. It's actually on 37 shifted left 20. We could do that as well. That's not a bad one. And this one's detected that it's 11. So now, instead of this memory A here, we can just do dump I testcode.bin.immediates, and instead we get, oh, I'm in the wrong directory. Come on, thank you very much. And that's a much better result. So we actually get, yeah, so we get this oddity here that it's saying equals 0 because it's not actually doing a, excuse me, a comparison, a constant value. I wonder if we can get a shortcut here by checking if there's a hash anywhere in the expression. That'd be quite useful, wouldn't it? If there's a hash in there, we go into the decoder, and otherwise we don't. All right, let's do that. Find this code here. Right, we don't need the message trans bits anymore, although I probably will come back to those later. Later might be next week, actually, come to think of it, but we'll see. So we've already gone through the string here. What we could do is as constant. Oh no, it's only gone through the mnemonic there. So I can't easily do that. But I mean, we can do this if and structure bracket and then not mnemonic. Where's the actual values? The values are in args. Right. So now we'll only go and process that if it's got a hash in there. It should make it a little bit more helpful for us. There we go, that one doesn't return a hash on it now, a number on it now. But we're still only getting these ones, so let's see what we can do here. Doop doop doop. So I'm trying to work out, so here's RISC OS Pyromaniac, right? And if we have a look in disassemble.py, the ARM disassembler here. So if I look for MOV in this, MOV, right. So this is how we decide whether to do it in the MOV instructions. And in the Pyromaniac code for MOV instructions, we actually get for MOV, comp, tech, and tust, all because they all have the same value in the immediates. So that's not too bad. So this could be the way to do it. Same sort of thing. There's more complexity here because we can also do special cases in here for whether registers are present and things like that. There's more clever things going on there. Andrew says it's cool watching ideas happen in real time. Sometimes it's good. Other times I've worked out what I'm doing ahead of time. This time I'm not doing so well, but I hope it's useful nonetheless. Yeah, because I've got here's the MOV ones, and this is the ones for LDR and STR. And the difference is, of course, that in Pyromaniac it actually can have live registers at the same time, not just live constants, and there can be live memory as well. So you can actually be decoding it as it's happening, which we don't do in here in the new module. So at the very least, these 4 instructions are all good for us to use in the same way. So let us do that here, because we know that they're all suitable in use for this. So we have any of these, or oh, this is going to be tedious, isn't it? Do. Yeah, I can go with that. Let's see. P T. I'm going to hope that the compiler will do a good job on this, but if it doesn't, then it can always be changed in the future. Maybe I should have just used strucump and astronacump and just been done with it and not cared. Yeah, probably I should. Mov, cump, tech, tust. Okay, so with that in mind, go over here. Cump, R1 common number. Tust with 3400, and actually you'd be, if you were doing a tust, you'd be testing for a particular single bit, wouldn't you? You wouldn't tend to do it that way. Although in fairness, you might do something like 101 there, x101. Except you can't do that because that's not a valid constant, is it? Too many registers. 1, 2, 3, 4, 5, 6, 7, 8. That's right, yeah. And then finally tech. Okay. Right. So those are a few values. CD test code, mate. Oh. Oh, you can't do a tust with a big value. Oh, because that is too big. That's why it should be that. And that's too big, so let's just make it that. I think that will work. Well, there's also CMN as well, isn't there? -8. Okay, and then we can test that and show that it is only decoding the MOV instructions, or that it falls apart completely. I mean, that's also true. Oh, that's because I left the bit of Python in there, didn't I? Oops. Right. Interesting. So yes, of course, it's not just got the MOV instructions, it's got the cump instructions. Yes, yes, 8. That's redundant, isn't it? So we don't need to do that one. So if im is less than x100, actually, if immediate is less than 100, then it could be a character. So if im is greater than or equal to quote space, and im is less than or equal to quote do I want to include high bytes? Probably not. Let's not bother with that. We should put commas between them as well, shouldn't we? Actually, if comment equals null, assign it to the buffer. Else, strict comment, comma, comma. And I'm going to need to do that on every single time I use this. So what I'll do is I'll just start add comments. No. Yes. No. I don't know. What am I doing? That does make sense. I'll put this in, but I don't think I'm going to need it on some of these things. This is starting a new comment. Should also wrap it in the usual do while sequence. So this sequence just means that you can write new comment semicolon and make it look like any other piece of code, even though it doesn't look like code. So that the semicolon matches ends the statement there. It also means you can put it inside if statements and things like that without it breaking. So if this is true, then it's a new comment, and we'll put equals quote %c. Oops. Im. Yeah, that's right. Otherwise it isn't, and then we'll just pass through. Okay. Let's just try that. So that should make this 65 turn into a capital A, and that 8 should just vanish if I've done it right. Oh, I've lost this one now. The hex one here is gone, and that's gone. That was never there. It's gone. That's gone. Okay, why did I? Oh, this one here. Yeah, I missed one off there. New comment. There we are, that's better. Is that meant to be comp8 or was that meant to be CMN? I thought I meant that to be a CMN. Compare. Oh, no. The compiler's gone, oh, compare negative with -8. So you mean compare negative? I'll negate that, and then that's just a compare, which is not what I wanted. I also need to compile that code, assemble that code first. Make. Hi. Right, there we go. We've now got the value A there, which is quite cute. Right. I think I'm going to go and commit that now because we've now added some more bits. Commit -A, add text instructions. Actually, we probably do this all on the add subs and all the rest of them, all the other arithmetic and binary operations. Yeah. Did I? Oh, I don't think I actually added the test code, did I? Oops, that's not spelt right. Test code. Yeah, git add testcode/makefile, testcode/s, and testcode/bin. Status. Testcode/gitignore. Right. Okay, that looks good to me. I just did that. Okay, I'll push that to the server, so if anyone wants to look right now, they can. Okay. Right, so we've got the mobs, and as I said, we probably could do this with the other ones as well. We could do it with the adds mobs. So we can do a sorry, I should explain what I'm doing. I'm just going to go and make this into a macro so that I can, instead of having to write it out, I can just have them check it. I think the compiler is going to be very sensible and just pull that out as a set of constants. If it doesn't, then that's tough. More, this is way clearer, and we can convert that into a strunner comp in the future. So, and that makes it a lot easier for me to read as well. Comp tech, just what's after test? Oh, add sub. What other ones do we have? Oh, it's just with binaries, I suppose. Or, oops, and pick your. I think that's all of them, isn't it? If I've missed any operators, I'm sure somebody will spot them. And we can go and add those to the tests as well. Make sure we're actually going to hit all of them. Simple mobs. Static operations. Binary operations. Oops, a bit much there. R1 comma number 5,000, 4,000, and 8 of this count. 2, 3, 4, 5, 6, 7, 8. Because that should also be a valid constant. Again, ors will probably just be bytes, so let's do 1 shift to the left 9, and probably a mask, so let's do ff. That's better. Bic off the top value, the top bits, I suppose, and eor. Clear off the bottom and the top. Invert the top, bottom, and the top. Sorry. Right, there we go. CD miners make. $5,000 is no good. Hex 5,000 will do. I don't really care what the number is. I don't think there's any special numbers that I really want to worry on there. Okay. And then let those. Where's the test gone? There it is. See, those are quite interesting, aren't they? Yeah, I think they're not too bad. And these are all quite amusing here. So for some of these it might actually be useful to have them as being shown as negative numbers, but I'll have to see what we can do anyway. Actually, if we just do less test code bin slash, this is using similar to the Pyromaniac code. Yeah, so in these cases we actually got negative numbers coming out here. Ooh, that's interesting. That's interesting. I think I might have got that conversion wrong, because that should be -8. I think that's the difference between compare negated and compare negative, which is very slightly different on that. And it looks like a disassembler bug. I'll have to have a look at that in a later time. Again, we've got bit numbers and we've got shift numbers, and we've got actually negative number here being printed, which is quite cute. Yeah, so maybe those should be printed as negative if they have got the top bit set. Not quite sure. And some of them probably shouldn't even bother, because that doesn't make sense to be. You don't care what it is in as a negative number there. It's always going to be a set of bits. All right, so that aside, let us try and see what we can do with this. So we've got all of these now working. Let's see if we can put in the extra bits here. Oh, right, so what I've done here is I've got a hash to say this is what the number is, and then equals. All right, let's go and see if we can do that. Actually, I put them right close to the actual one, so I'll do that. All right. And actually, I'm not joining these with that. I'm joining with space equals. Oh yes, I can do this. What I can do is, oh, come on. Let's try to copy hash. Into otherwise do equals. So we don't put this on here, we just write down the extra thing that we're adding, the value we're adding, and then that's all good. All right. So this gets us those constants there, the first digit, and then we can try and do other numbers here. So like this one is a value shifted left so many, and that's really easy to do. Int I, actually we'll name it properly, shift, because we just step through it in steps of 4 to see what they are. So for I equals 8, I is less than 32, I is equals 4. If immediate value shifted right by I is less than actually value, put it in variables so it's a little bit easier to read. Immediate value shift left I. Firstly, if value I want to know if we've just missed anything, if there's any values below that. Oh, come on, brain. If im and 1 shifted left I minus 1, and we only want to do this in any case if im is greater than 256. If value is less than 256, not return, break, jumping out of the loop, not giving up entirely. Oh, my head is pounding. I'm going to need to take a break very shortly. This is percent I, shifted left, percent I. Value, comma, I, and then break. Think that's right. Let's have a see. Oh. Undeclared name. Oh, I said I was going to call it shift and then decided immediately to go and call it I. There we go. Better. And what do we get? That new comment didn't work. If comment is null, oh, we didn't actually assign to comment. We don't need to assign to comments here, it's already good. Offset equals 1. Offset plus equals 3. I could have done, oh, doesn't matter. Oh dear, I've missed my braces somewhere, haven't I? Oh, I missed one there, that's why. Missed an extension. That's more like it. 37 shift left 20, 16 shift left 20, 252 shift left 24, yeah. 80 shift left 8, yeah, fair enough. That one, interestingly, didn't do one. Ah, because it's only starting at a shift of 8, so that doesn't get caught. I think that's probably fine. I mean, I could make it a shift of 4. Yeah, I could make it a shift of 4, couldn't I? Let's start with a shift of 4, then we would catch that one. This one's 2 shift left 8. All right. And then if we want to include bits as well, we can do other things. Now, if I remember rightly, there's a magic trick for this. There is a magic trick for this. Oh, I can't remember it. It's something like immediate and immediate minus gets you the lowest bit, gets you the highest bit. No, it doesn't get you the highest bit. Oh, I can't remember. Find highest set bit. Oh, go away. Oh, come on. Or is it lowest set bit then? Find lowest set. This is where Dave would be helpful, because he always knows this bit twiddling stuff. I used to be quite good at spotting these, but okay. Right, I'm going to go and just go, I don't know off the top of my head, and I'm going to see if I remember it later, because I'm sure there's can't trailing zero. Check if a number is divisible by a power of 2. That one. No, that's not the one. It's a particular power of 2. Clear the rightmost set bit. Yeah, turn off the rightmost set bit of a number. So if im is not equal to 0 and equals 0, only one bit is set. Yeah, I'm going to be lazy. Oh, actually, no, we can surely do this. We can surely be clever with this. At least vaguely clever. Value equals in. If value is greater than 16, then value equals value shifted right by 16, shift plus equals 16. So that shifts it down to there. Then we do the next one, which is 8. Actually, it should be greater than or equal to, shouldn't it? And this should come out relatively efficient. I've written less than or equal to and I meant greater than or equal to. That's going to get me a very bad number if I did it that way. 2, 2, 2. There we go. That's better than iterating through it. And then we can go bit. Let's see if that works. Yeah, that looks like it's doing the right thing. It appears to have given me the correct value for this bit and this one here, so I feel comfortable with that. Cool. All right. Let us try running the test code. So if we just do debugger D, we'll have a see what this comes out as. Yeah, that was a lot of stuff. Oh yeah, there's always that value as well, isn't there? The shift values. So okay, start from the top. Yeah, that looks fine to me. Bit 7 shifted left 12 would be bit 19. So we haven't got anything for the MFNs nets yet, rather. That's not very interesting, so it doesn't do anything for it. Bit 0. That may not be the most interesting of things to do. We may want to just skip that one. Actually, is it even sensible to report bits? What do they do in Pyro? Let's have a see. Here's Pyro. So bit space. Never report one shift left bit as that's covered by the bit number check. So that's what we've done with those. Maybe that's something we can actually do here as well. Yeah, in fact, probably we should. Got the bit number checks. We've got character checks there, hex values, negated values, and positive values. Right. I think these translations, the bits are definitely here somewhere. Bit percent, yeah. So actually, we do set those bits for all of the bit values, bit 0 all the way through to some bit numbers. That's right. We never do it for any value between 10 and 0. What, 10 and less than 0? That's odd. Fine, I'm not going to worry about the logic on that, but anything that's, we only handle it for values that are greater than 10. So that seems to make sense, I think. Oh, wrong one. I'm in Pyro. Let's go back over here. So let's go and do that. In fact, we can probably do it here, can't we? Now we'll do it on this one. If im is greater than 10, so that'll ignore a couple of them, which is probably a good idea. Those there, got D's, yeah, seems sensible. This looks pretty neat, actually. Right, output this to mine. And I believe I've got Pyro's already output, so I can just do a diff. Oh, apparently I haven't. Give me a second. There you go. This generates Pyro's version, and then we can do the comparison. Right, so yeah, opposite way round. We say 1 to 8 shifted left 12, it says just bit 19. I mean, I'm not going to complain about either of those, they both sound sensible. We have not negative values done yet, fair enough. These, yep, same sort of thing. They report a negative value, we report a positive value there. Actually, I don't mind that. I don't mind that at all. And Pyro's got this weird odd shift it decided to do there, where it gave me that as 17 rotated right 30. That is an odd way of encoding it. Apparently that's what Objasm built. Yeah, different case for these, don't care about that. Again, these are the same values, I think, so it doesn't matter. Yeah, they've got a slightly different way of writing it. Yeah, nothing special there. Negative values not decoded again. And we haven't done the MSR stuff. We could look into that, but I don't think we need to right now. All right, I'm happy with that. So let's get that merged. So what we've done. Not added anything else, have we? So all we're looking at is the arithmetic instructions, bit value, and bits and shifts. Added arithmetic and Boolean instructions, bits and shifts. And the Boolean binary instructions, isn't it? Not Boolean. Instructions. Bits are recognized in the output and in the immediate, and the shifts at nibbles are undone. Okay. Right, so I'm happy with that so far. I'll push it so that it's available to other people as well. I'm going to go and take a break now, have a cup of tea and, well, probably not a cup of tea actually. Well, it might be a cup of tea, might be pineapple juice, not sure. We'll come back with a drink and a short rest. So it'll probably be about 10 minutes, I expect. Yeah. All right, see you in a bit. Hello, we're back. Just about. I'm just finishing a little bit of my gingerbread. Oh. So, before the break, we had a pretty good set of work to get the constants, immediate values, decoded, but we're currently missing these ones here, the negative values. So we're going to have a look at negative values next, because that'll knock off a few more of these differences. Not so many of these ones, but the other ones, yes. Oh, ADC and SBC, I forgot about those, and RSC. So those are the carry-based operations. You very rarely use them unless you're doing actual low-level maths, because it's not as necessary. I don't know if the compiler will actually produce them. Probably will. I don't know if the Norcroft one will though. Anyway, so yes, those instructions are being missed off at the moment. So let's do the carry-based ones first, and then we'll move on to negative values. And then that should be pretty good. Right, so that's add sub and RSD. According to those with ADC, SBC and RSC. All those should now be decoded because that's all it needs. And we need to put something into the code that will test it. Now we'll just use the same ones. Might as well. ADC, SBC, and RSC. Yeah, that's pretty much it. Minus make, build those. And then go back to here, and then we can test them. Except that was not what I wanted to do, was it? I wanted to do the dumpy thing, to dump the immediates, that's it. Although actually these did have some negatives in, didn't they? Some, not negatives, some RSC and RSC, there we go, but not, yeah, but not for constant values, which we have here. ADC, SBC, RSC now have values. Awesome. Okay. ADC, SBC. Okay. So now we're going to go and do the negative values. So let's have a look at these. Find the file again. Here we are. Where it is. So the way we handle this inside Pyromaniac is we actually have a separate function that handles the immediates and says this is negated, which apparently was wrong as well for the comparison. So we'll have to look at that. So yeah, that'll be a little bit different, but not a problem. So probably want to lift all of this section here and make it into a single thing. Yeah, this whole section here. The easiest way to lift this, I think, yeah, just this bit here, is to do something like comment equals decode immediate brackets d.im. and that will give us the immediate value we want. Okay. Right here, static const char star to code immediate. Ah, I've already got my brace, haven't I? They're already in here. 1, 2 down. Okay, and then we return comments. I think we also need to move the comment buff and our macros into here as well. So let's just pick those up. Firstly, comment buff there. Go into here as a static. Nice and easy. And then the new comment, oh, I don't need the mnemonic match because that's actually just here. There. Okay. So we also want now to put in, that's just refactored, does it still work? No, it does not. Ah, because that's not needed anymore. Oh, and then you need a comment buffer done, so I actually just jar star comment equals null. So it starts out null and then we go and assign to it. Qualify losing implicit caster pointer at line 293. Yes, it would, because that's, I've made it a const jar star. There we go. Build. There we go. Test. Oh. Yeah, I think we're going to have a quite short second half today because I think my head is getting very woolly. Right, still working. This is good. I wonder if it's useful to do a shifted left by a number. So you can actually do 65 shifted left 24. That'd be so rarely used, wouldn't it? Probably not sensible. Anyway, we're wanting to handle negative values now, don't we? Negative value. I was wondering what I actually do. So we've got negated in here. And if it's negated, we invert it. But there's also a negative one, clearly, because MBN and CMN are different things. Yeah, well, we'll do it this way then. So, enum positive, it's negative, it's negated. type underscore d. Oh, sorry, I should call it there. If it equals it negated equals not it. Else if it negative minus it. What do we actually do in sorry, you can't see this. If it's negated, we do that. And then what do? We've negated, we produce the negative value there. I think what I'm going to do here is if it's positive, else exactly the same but as a signed value. Let's just have a look at that and see what we actually get out of it. So all of this is going to be it's positive, but then we've got some other cases for other ones. So MVN, CMN, that's all I'm going to handle right now. It's negated, otherwise it's negative. Shouldn't that one have been turned into a negative value then? So what should have happened there is it would have passed in the immediate value of 1, which would then have got negated, which would make it a -2. I think it's -2 it's meant to be, isn't it? Isn't it? I don't really know. Oh, sorry, not the binary. I don't really know that. That's this one. Yeah, -2. And then we should have, but that should have been a big value. So it should have been lost where it was now. So coming into here, it will go, it's negated, so it will go and invert it. Oh, it! Actually, im. And in fact, I believe it was actually telling me that in the error messages it printed out. I believe these things here, what it was telling me, yeah, it was telling me I shouldn't have done that. Yeah, that's better. -2, -8. That's actually really cool. I'm actually quite pleased with that. Yeah, quite pleased with that. One shifted left. 31, sorry, yes. Completely forgot what the value of the top bit was. If the top bit is set, and we've got it equals it positive, if it thinks it's a positive value, it's not been negated, then equals minus except the top bit can't be set there. I'll put it in the wrong place. If it's positive, now I won't include that in there. I think that's okay. Yeah, I think that's okay. So we've got positive values, negative values now discoded. Nice. Okay, there we go. I'll do it for now. Right. So that's now given me those. Push that as well so people can see it. Not important. So, what else do we have in the Pyro output? Those are all good. So they're doing negative values for those, even though they're not. No, I think actually I'm doing reasonably sensibly with what I've got there. Those, yeah, not a problem. And those. So I could do this decoding of those there, I think, probably. Is it really that interesting? Not sure. Oh, didn't we have an oddity with the RRX? What does cat mine? Yeah, we get RRX number 0. So we probably want to replace that. Easiest way to replace that is just to get rid of it in here. It could be in any of the arithmetic ones. You know what? I could just bolt it onto these actually, couldn't I? is encoded as. If I'm just going to do it this way. Oops. Oh, brain's really not playing ball today. Structure. Args. If there we go, that'll kill that one, I think. Let's just quickly check that. Oh, not structure, sorry. Yeah, that's also not meant to be a double equals. Thank you for that. Okay, I'm going to run the debugger. Come on. Right, there's our RX fixed, so that's good. Status. Okay. So we've now got some comments in there for the various instructions. If somebody wants to add in the extra magic for particular instruction after something else, or don't do this on this architecture, they can do that. That's not a big deal. It's actually in the code. There's comments in the code now, so you can do that. And that also means that in the task list, instruction comments on constant values can go, oh, actually it can't go over there really, but check out master, merge, add comments for immediates. It's now on master. Okay, so we do have other things on here. So we've got the ARC64 disassembly, and we've got the disassemble ARC implementation. Can I just check whether, just out of interest, what happens with the thumb decoding? I haven't looked at thumb in a while. Huh. Yeah, that seems good. So yeah, and it seems to have given us. So those are wrong, CBZ and CBNZ, because that's compare and branch if 0, compare and branch if not 0, and those are the offsets. So that's probably the same as these branch instructions here. So I need to go and decode those. This was not what I was expecting to do right now, but that's not a problem. That's the P operations. Those are branches. Did we not fix up branches? Huh. LDR PCR with relative. they're only special to this. Interesting. Okay, so let's just stick that in, I suppose. Oh, there they are. Sorry. If we've got a plus, a number and a plus, this is a PC relative like that. So why did that one not decode? Oh, because it's not at 0, it's a little bit further along. Okay. Let's just add in special cases for these. Okay, so if args, no, if, see here we use string comp. Why didn't I do it back then? String comp. I'm sure there are good reasons for these things. Mnemonic, comma, CBZ 0 or CBNZ. So Charles star. Looks like we copy to the new args from args. Args equals new args. Only if we actually see it will we actually modify what's there. And if we do, we put it in with JS plus dm at hash plus. I think that seems like it'd do the job. Yeah, we'll see how that goes. Yeah, still writing Python code. Oh, comma 3, comma 4. Come on. That looks more like it. So this is mine thumb. And this one is pyro thumb. We compare thumb. So see. Interesting. The addresses are different. Of course they're different. The values are going to be different lengths. So yeah, so it's the immediate values are going to be offset slightly. It says 72. This one says 76. So they're 4 off each time because the pipeline is two instructions, and 2 instructions is 8, but only in ARM. In Thumb, it's 4. So this one's always going to be 4, and this one is going to depend on what the architecture is that we're decoding. So just fix that here by doing bracket thumb, 4, 8, and mine, let's update mine. Okay. You done? Thank you. Reload the file. Better. So looks like we're still leaving the numbers on there, which I can probably get rid of later. That's good. Means it's a bug in Pyro and the disassembly stuff. This one, star. Oh, maybe we're shooting. No, that seems okay, doesn't it? Yeah, star. Hex 30. Interesting, it calls them MOVS there. We don't call them MOVS. I wonder if that's wrong. I don't know. Ooh, PC relative is also wrong here. It's probably the same reason, I think. Yeah, I think that's probably just the same reason. So let's go back to this and have a look at the ADRA. Yeah, there. And as that's now become rather long, I'll just put them together there and move that bond from there. Has that got one as well? Yeah, looks like that LDR's also got the same thing. So we'll do the same here. Okay, let's give it another whirl. So, what would we just fixed? It was this ADRA, wasn't it? Yeah, there we go, that's now right. That's good. That one's correct. Drag links, yeah, all looking good to me. Feel pretty comfortable with that. All right, so this is, what do we do? We've fixed thumb decoding. Fix for thumb decoding of CBZ / CPNZ. Check and branch if 0, not 0, instructions in thumb still being treated as branches in the other style. All right, there we go. And that I'm pretty happy with. So we've now got thumb working. Oh, now fixed because it wasn't working, I suppose. where I was going with that was, is it worth implementing debugger disassemble architecture? Because that would then give us more compatibility with the Pyromaniac version and start us on the route for making it 64-bit capable. So let's go look at that. Debug arc, architecture to use. Yeah, fair enough. Pointer to instruction bytes, number of instruction bytes supplied, address to assume the instruction came from, output buffer, size of buffer, and the flags or default. Okay, that looks pretty simple actually. Let's go for it. Let's get that done. Can we get that done before 4 o'clock? I doubt it. But we'll give it a whirl. What's the worst that can happen? I know you should never say that. Where's my SWI list? SWI list, SWI list, SWI list. Yes, what number is this? This is 385. Okay. Looks like we're going to have to pad these out with the other ones, which are 2 is debugger flags. Oh, sorry, no. Debugger flags. SWI debugger. We won't support that just yet. Disassemble plus, still not supported. Gets us 4, and then 5 is disassemble arc. All right. So. Go to module. Where's the module? It's in veneer, isn't it? So we're going to need a bunch more. SWI entries. Oh, I missed the SWI. Here we are. Here's SWI entries. So each of these, there's going to be. Sorry, I've forgotten what they were again. Debugger flags, and that takes big. Your just for now, we'll have them as being not supported. And the next one is disassemble plus. Which has, oh no, that one there. Go back to here. And it's exactly the same as before, but we've also got flags to use. Again, not supported. And then our new call, which is disassemble arc. Which looks like this. Well, that didn't copy great, but not too terrible. Oh no, that's the on entry. Fine. And then on exit, we have a similar table, just looks like this. Alright, that'll do. At least I've got them noted now. Right, so this one is architecture in R0. Now the number of instruction bytes supplied, data len 1. Uint 8, isn't it? Oops, uint 7. Uint 8. 2. And 4. So 3 is next, isn't it? Oh no, the address to assume it came from, sorry. Address is in 2. Pointer to the buffer. Hang on, did I get this wrong? I'm misreading it, aren't I? R1 is the pointer to the instruction bytes. There. Then the number of bytes that were received. Yeah, 1, 2. 3 is the address it came from. 4 is the output buffer, because we now have a it's more sensible. And start output. Is in R4. And then R5 contains output len. Finally, 6 contains the flags. Okay. If arc equals 0, then we're going into the this is, what is this? This is arc32 on. Word equals star okay. Right, so we can return 0 minus 1 there, so that we haven't got one. If R5 is of 0, buffer overflow will be returned, and R5 sets the negative value. So we can actually do that here. If data len is less than 4, check what the values need to be. -1 is the current architecture. If arc -1 arc equals 1, else arc 0. And then we update with the architecture that was in use. If data length is less than 4, r bracket 5 equals minus 4, because we need 4 bytes. Yeah, and that looks okay to me. Otherwise, we can get the word. And then we can just call the same thing we do here, except it comes back in a constant string. Otherwise, r to r5 equals 4, because we're only going to use 4 bytes. And on this one, string of disassemble word 0. We update the pointer to the next instruction byte. So R1 will be data plus 4. Number of bytes remaining in the buffer, R to R bracket. Oh, sorry, that wasn't meant to be 5, that was meant to be 2, sorry. I'm trying to follow the text that I've got here, and it's not, I've got the wrong values. To R bracket 2, so this is the number of bytes left, will be data length minus 4, sorry. R3 is preserved, R4 is the pointer to the null terminated text, or could be the 0. So if output equals null, there's our buffer, so R bracket 4 equals str. Negative number of bytes. Actually, this is going to be 0, isn't it? Because there's no bytes left on that one. Otherwise, they supply the buffer. If r to r bracket 5, no, sorry, not. If output len is less than strlen bracket come on, brain. Str plus 1. Buffer overflow, r to r bracket 5 minus. That's the amount of space we need. Needed equals that. And R4 can be its internal buffer. R6 is always returned as the length of the disassembled text. So R to R6 equals strlen str. Okay, well that was nice and easy. Word size equals 4. 3 for thumb. Right, so this will give us the word size. So now I can go plus the word size, 2. Word size. Can't spell. You keep writing arc. Arc equals 3. 0, otherwise 1. Should really have a constant for that, but I haven't got one at the moment. I'll set that up later if I need to. What are you complaining about here? Syntax error, it says maybe I saved it the wrong time. Ooh, missed a semicolon, that's why. Right, so I just need to get the word out here. So that's actually going to be if word size is 2, else, just like that. That's actually kind of cute, really. And I think that's all we need. Again, I missed the semicolon. Else, unsupported arc. Oh, and of course that returns null. Almost certainly I've missed buffer overflow and unsupported arc from this. Do we have those defined? We don't have a buffer overflow. Unsupported arc. It's not supposed to. And buffer overflow, which it described explicitly as error 1E4. Okay. Build. Likelihood of this working? Pretty low. Implicit cast of pointer to int. Fair enough, we'll do that. Variable flags declared but not used. Correct. Not currently used. Implicit cast of pointer to int. Yeah, that was wrong. I should be doing uint. Put it to there. And then, oh, I missed my star off there. Okay, let's try that. Passed arc declared but not used. Did we never actually bother writing the parser for that? Okay, I'm not going to worry about that one right now. May have to come back to that one. Warning, warning, don't care. Let's just Not worried about those. Not supported is where we're going on here. Okay. Just put those there for now. We can have a look at those later. Build. Built successfully. So with that built successfully, what did we just do? Oh, we did the architecture stuff. So architecture. I forget how this works. Debugger assembler uses a sequence of hex values for input. So let me just find. Actually, the way to do this is to have a look at how we do it in Pyromaniac, because clearly we'll be calling it in here. So if I look in PyModules Tuxt, maybe it wasn't in that one. Maybe it's in this one. Debugger space A. Huh. Am I not even using that? That would be very odd, would it not? Or maybe it's in Debugger Swise. Ah, here we go. Yeah, these sorts of sequences. So we've got Debugger. I don't know what that does, but that is an instruction, so let's give it a whirl. Move that to the top of the screen. We can look at it. Take off bin slash at the beginning of that. Bad SWI. Did I not just add that SWI? Did we not just build it with that SWI in? Have I got the wrong number? Have I gone and put it in the wrong place? It's always possible. Let's have a look at that's Pyromaniac. Don't need that. I need this here. So SWI numbers 0, 1, 2, 3, 4. It's 5. Okay, so I've missed one. Back to the top. So disassemble, yeah. Disassemble thumb, that's my next one. Flags is 2. What's 3? Where's 3 gone? Okay. Debugger.py. Oops, that's not what I meant to do. Oh. Okay, big, please. Thank you. Give me the SWI numbers. Apparently I've not even got the SWI numbers in this one. That's the wrong debugger module. It's this one I want to look at. CPU. Apparently that's a debugger plus one as well that I don't support. Well, I'll put it in there so we don't say we don't support it. I imagine it returns the CPU details or something. I don't really know, but... Oh, hang on, that should just be flags, shouldn't it? SWI flags, SWI CPU. Okay, I'll go back to our veneer. It's actually called flags there. And there's also a CPU, which we just don't support at all. Build. Run. Should have got an error when reading the disassembly size. Okay. I wonder if that's because they pass in we pass in null initially. Probably. Config trace SWI traps equals debugger disassemble. Let's see what we got as our parameters. So input parameters. Yes, we passed in R5 and R6 as 0. Are 4, 5, and 6. 4, 0, 5 is 0. So both the output address and the output length are 0. Which is... Right, since that is the interface, I'm going to go and implement it, but it's not a very good interface. I'm clearly screwed up on that one a bit. I can always add it. It's not like anybody else is going to be using this one at the moment. Now we'll get an error. Or we should get an error anyway. Give it a whirl. Buffer overflow. So they call it once, and they get back a minus so much space needed. And then that says 24. Yeah, fair enough. So we go and disassemble it again. And then we say, no, that's buffer overflowed again. You know what, this time I think the problem is that we're modifying things before we've returned, only when we're successful. should we modify the output pointers? I could probably turn off this tracing actually. Oh, sorry, I missed some messages. Yes, Jason, I'm creating a disassembler, use it for ARM instructions, and it doesn't work. That's good. Oh, partly because I haven't actually copied the disassembly into the right place, which is a bit dim, but there you go. Stra copy, stra to not around output from stra. There we go. Sorry, Jason. Yeah, I'm building a disassembly tool for ARC32 and eventually ARC64. Not right now. So that instruction appears to be doing remaining input bytes 4, 2, consume bytes 4. That is correct. With that, I've now got disassemble arc working. With the exception that flags isn't supported, but that's fine. We don't support it anyway. So, add support for debugger underscore disassemble arc. Okay, with that done, I think I'm going to call it a day. It took me a little longer than I intended after 4 o'clock, which was what I was trying to aim for. Before we finish though, let's go and mark this as complete because we've now done it. This one here is now done. So next week, I'm going to be attacking ARC64. That's going to be a exciting and fun one. I'm sure it'll have its own set of problems, but the bulk of the code that we've got right now should be working okay for that. Right, so today though, what have we done? We've done comments on immediate values, so we can actually see what's going on there. Where's that gone? That's this code here, isn't it? Test code bin immediates. That looks like it. So we can actually see comments on those to see what values are there. That's one of the big niceties that I've added to the other parts of the disassemblers that I've done. We fixed some of the thumb instructions so that they now produce addresses that look right. And then we started adding, or we have added, sorry, the disassemble debug arc SWI, which gives us the ability to disassemble other architectures in the future. So we'll call it a day there. I'm glad that we've had some people having a look here. I hope that it's been interesting for them. Again, we'll be back next week to have a look at this. In theory, in theory, we'll start on the disassembler. The way that I'm going to approach that, I'll talk about this more next week, but the way I'm going to approach that is that it will be a disassembler that will be ported from one that already exists. So port it separately. We'll put together a simple dis file or similar test function, and then we'll integrate it into what we've currently got. Might mean we'll have to split this up a bit, but that's what we're going to try and do next week. All right, thank you for watching. Again, if you've got any comments on things, please drop me a line on the RISC OS open forum under the thread that we've got there, the different posts that I've been doing. And I'll see you all another time. Thanks very much. Bye.